Hello, International Math 1 students. This is Mrs. Gillihan, and we are working in the Mathematics Vision Project curriculum. This is task 1.9, and we are actually looking at our RSG homework problem number 10. And in this particular problem, we are given a series of figures, and we're being asked to look at the number of black tiles, and our instructions ask us to determine the recursive and explicit equations for each. If the sequence is not arithmetic or geometric, identify it as neither and don't write the equation. So it is possible that we don't have an arithmetic or geometric sequence. So we're going to have to be very, very sure before we make a label in this case. So let's take a look at this sequence. In the first figure here, figure number 1, we have one black tile. Pretty obvious there. And then when we go to the figure number 2, we notice that we have 2 black tiles, and the size of the tiles in this case is irrelevant. They have just asked us to look at the quantity of tiles, just count tiles, all right? And then if we move to the third figure in the sequence, we notice that we have 4 black tiles. So we go from 1 to 2 to 4. And visually, we can see that we are doubling the number of black tiles from figure to figure. And when we double, of course, the common ratio will be 2 because we are multiplying the number of black tiles times 2 with each figure. That tells us that we do indeed have a geometric figure. All right, so we are going to circle geometric figure here, and then we are actually going to look at a table in order to confirm this. As I'm sure I've told you before, I'm a huge fan of tables. They help keep us organized, and they basically map out our equations and what we can, how we can put together our equations. So let's look at this in order to be sure. Figure number 1, and we set that up. Figure number 1, we noticed over here we had 1 black tile, so we put that in our table. Figure number 2 here had 2 black tiles, so we noted that in our table. Figure number 3 had 4 black tiles, so we noted that in our table. And we have to be sure that the pattern holds for the entire table. So if we go from 1 to 2, we notice that we did have to multiply by 2. And we want to be sure that that pattern holds when we go from 2 to 4. And it does indeed, we did multiply by 2. We have to look for that consistent pattern through all of the terms or all of the figures in our sequence. So now we are 100% certain that this is a geometric sequence, and we can start to write our equations. Okay, so we are asked to write the recursive and explicit equations for each of these. So let's first start with the recursive sequence. We know that 2 pieces of information are necessary. First, you need f of 1, and then you need your common ratio. All right, so let's the first line always states exactly, very, very deliberately what that first term is. And so f of 1 equals 1. So our first term, f of 1, is 1, and that's where we get this part of our equation. Now the second part of our equation states the pattern that is occurring. So if I look at the second part, the pattern that occurs for any possible figure, all right, that's what the n represents, any possible figure in this sequence, we would have to go backwards to look at the previous number in the sequence or the previous number of black tiles in the figure, and we would have to take that number and multiply it by 2. Very deliberately stating, okay, if you're looking for a number, go to the previous number and multiply by 2. The recursive function is helpful if you have a table already set up and you're just looking for the next figure in a table, but very often if we are looking for, say, how many tiles there are in the 15th figure, we would have to go to the explicit formula. And the explicit formula states that for any possible figure, all right, let's say we're looking for that 15th figure, for example, we would use this equation. And the way that this is set up, we have f of 1 right here, so our first term is right here, and then we are repeatedly taking that number and multiplying it by 2. So here's our common ratio. Our common ratio is 2, and we got that from our common ratio number. We were multiplying by 2 repeatedly here. And then if we were looking for the 15th number in the sequence, we would plug in 15 here, and we would probably end up using a calculator and put that to the 14th power and repeatedly multiply. So this explicit equation does all of that work for us, especially if you have a calculator handy. The recursive, again, is handy if you are simply looking for the very next term in a sequence or the very next figure quantity of black tiles.